Let's take another example and let's graph y equals -2 sine of x. And I want to see what that graph looks like over the range from -pi to 3 pi. To do this, I'm going to first start with the graph that we're familiar with, y equals sine of x. And then from there, do some translations to get a sense of what's going on. So y equals sine of x. And if I follow our 5 steps over here, I'll begin with its amplitude. As amplitude in our basic graph is a value that comes before the function. In this case, it's not listed, so it's an understood 1. So I know that the amplitude of this particular graph goes from 1 to -1. So its maximum height will approach that and touch that line, and its minimum height will approach that line. The second part is I want to find its 5 key points. On the basic graph, I remembered that it crosses at 0, crosses at pi, and crosses at 2 pi. Those are the 3 key points where it crosses the graph at. The other key points I want to find out, are how to divide the graph up into the 4 key sections. And the 4 key sections are defined by, if I take its total period, within one particular period, in this case, it's 2 pi. I divide it into 4 sections. I get that something fun or something cool is happening every pi halves. That's a key marker. So here at pi halves, something cool is happening. At another pi halves, something cool is happening. Another pi halves, something cool is happening. And another pi halves, something cool is happening. And so that's how we divide the graph up into 4 sections. And those sections have 0, pi halves, pi, 3 pi over 2, and 2 pi. So that's going to be helpful. Find out the corresponding y's. I know the graph crosses here at 0. I know at pi halves, the sine of pi halves is going to be positive. The sine of 3 pi over 2 is going to be negative. So I have enough points to go ahead and roughly connect my graph. Now, it's as smooth as I could do it. And then 5, extend if we need to. Right now I'm not extending because I just want to do y equals sine of x over the period from 0 to 2 pi. So now let's go back and look at our original problem. Original problem is looking at this y equals -2 sine of x. So let's overlay it on top and see what we can discover. First of all, its amplitude. Its amplitude in this case is 2, but it's a -2. I can look at my 5 points. Well, since I have the same sine of x graph, I know its key points are all going to be the same spots. So given that, let's just go ahead and graph it with our new amplitude. So we know that we're going to start at 0. At pi halves, the value of sine of pi halves is 1 times its amplitude, which is a -2, which flips it down here. So let's go ahead and extend our graph down to -2. And it looks like we have to also extend it up here to +2. So I have a point down here at -2. Comes back up here to 0. At 3 pi over 2, the sine of 3 pi over 2 is -1. Multiply it by a -2 makes it a +2, so I have a graph that's up there. And then I have enough points to go ahead and connect the dots. So it's going to go from, on the first section, it's going down, up. So there I have the function or the graph y equals -2 sine of x. And then the extra part, it wanted me to graph it and see what the graph looked like from -pi to +pi. So let's just extend that back to -pi and up to +pi, +3 pi. So we'll just extend that graph to there, and then that's going to go down and then up. Whoops, let's go ahead and connect it right there. I kind of ran out of room a little bit, so it's not exactly to scale, but I hope you guys get the idea. If I were to draw it again, maybe I would do a little bit better.